Hi everyone. So today we're going to continue our lectures into electricity. So far we've talked about series circuits, not just one type of circuit. The next type of circuit we're going to talk about today is something called a parallel circuit. Most of what you folks actually deal with at home and everywhere in the world is something called a parallel circuit. Electrons can choose which pathway they want to take. In a series circuit, you had to go from one resistor to the next one. Here, depending on how you lay it out, you can choose. Do you want to go from one resistor or to another resistor? In this case, the total current is equal to the current in each particular branch. So if you think about your classroom, there's about 20 of you folks in here. Let's imagine you guys were all asked to go to the gym. Some of you folks may go down the staircase right here by patio B. Some of you guys may go upstairs towards patio C and then down that staircase. Either way you go, though, there's still going to be about 20 kids leaving this room, and there's still going to be about 20 kids getting to the gym. So it doesn't matter which path you go, there's still going to be a current in both hallways. Each resistor uses the same amount of voltage. Adding resistors decreases the total amount of resistance. So folks, you could imagine, if you would, there's two people in the hallway telling you guys to slow down. There's an administrator, someone who can get you in trouble, or you can get punished if you're doing something behaviorally wrong, and then maybe a custodian. Okay? Even though the custodians are people in the room, in the building that you guys should listen to, you generally kind of curse in front of them sometimes. Or you guys are on your phones and doing some crazy stuff. Doing it in front of them is not going to bother you. So there will be a high current over there or low resistance because you're not going to do those custodians are not really going to stop you. But the talking to the principal, if the principal is by patio C, most of you guys won't go that way because you just don't want to deal with it. Some of you guys will, especially some of you good kids who won't be in any trouble at all. You guys will go that way. But generally, you guys follow the path of least resistance. This equation right here is how you find the total resistance in a parallel circuit. 1 over RT equals 1 over R1 plus 1 over R2. Now, before you say to yourself, Mr. Kess, can't we just get rid of the ones? No, that's not how the algebra works. This equation is if you're given the resistors straight up. But there's another way that you could find the total resistance in a parallel circuit, and that's looking at V equals IR, Ohm's law overall. So here's an example. Look at the circuit diagram below. What is the total current? What is the total resistance? So as we talked about before, commonality says we leave from the positive side and we get to this break. So the electrons could either go through R1 and then head back towards the battery, or they can go through R2 and meet up again. Length is not an issue. It's not an issue of length. So if the R2 path is a longer path, for our purposes it's going to be, an electron's not going to care about that. But the electrons will look at the actual resistors. If you focus on this part right here, okay, the voltage here is going to be 9. The resistance for this particular part is going to be 10. So if you look at the equation for Ohm's law, V equals IR, in this case here, 9 equals I10, because we're looking at just this particular resistor first, we get a current in this particular branch that's 0.9 amps. The same thing can be done if you focus your attention on that part, just going through R2. So in this case, V equals IR, 9 equals I4, so the second current will in this case, equal 2 point something. It's 2.25 amps. So just like I explained to you guys before, if there's 0.9 kids in one hallway and 2.25 kids in the other hallway, the total current is going to be these two added together. So the total current in this case is going to be 3.15 amps. And if you guys look at the picture, once again, the current in this particular spot, oops, sorry, wrong button. The current in this particular spot pairs up with the current in this particular spot. So depending on where you are, where you're watching a security camera, you're going to get different values of current. Now, this leads us to the last question here. What is the total resistance? As I mentioned to you guys, you can use the new equation, and we'll do that way first, just so that we can say that we tried it. 1 over RT equals 1 over R1 plus 1 over R2. Okay? So in this case, 1 over RT equals 1 over 9 plus 1 over 4. So in this case, 1 over RT equals, you could round here, it's a little bit, it's okay, 0.11 plus 0.25. So you get 1 over RT equals 0.36. And when you guys get to this point, even though we're in the month of April and you guys are a little bit stronger with the math, you could still set this over 1 and cross multiply it. So if you do this part correct, you should be getting an answer of 2.77 ohms. So that's one method you guys can do that will always work. 1 over RT equals 1 over R1 plus 1 over R2. But there is another way to address the topic of total resistance. We already know the total voltage, the voltage we started with, is going to be 9 volts. We also figured out already what the total current was from the previous problems. In this case, the total current is 3.15A. We're asked for the total resistance. So we can use Ohm's law one more time. In this case, 9 equals 3.15 R to get R total, of course, being 2.85, like that. Now, I'm sure you guys are freaking out, for you guys who actually care, and you guys are my favorite, the ones who actually care. Okay? These numbers are not the same. What is going on here? Well, if you guys remember, there was one time in this problem here where we rounded. And that's why our numbers don't match up perfectly. If you guys did either of these methods in class on a test, you would be right either way. So when you guys are comparing answers to your friends, like I always say, just be careful about the rounding. But as far as I'm concerned, these are the same answers because your method is perfectly valid either way.